Hi, my name is Dimitri Vanwell. I am a Wayne State student, and this is my project for ECE 3620 Intro to Microcomputers. The following project, we were given choices between what to build using ARM and the TM4C123G Texas Instrument chipboard. This, for my project, I chose a pedestrian stoplight for green, yellow, and red lights with a pedestrian button that will take it from green to yellow. I also had a delay to that. We'll see that later. And then there's a 7-segment display that every time a yellow light is produced, it will count down from 10 seconds. There will be 30-second intervals for green and then 10-second intervals for yellow and red. Next, I'll be showing you the circuit in working fashion. So give me 1 second. Let's pop that up. So yeah, you can see we have the circuit here. My phone is there. I'll also be using this as a timer to show you that there's accurate delays for each. So you can see we have the board right here. We're using port B for the 7-segment display and port E for the LEDs, and the interrupt is the last pin available on port B. So I'm going to go ahead and fire it up here. And then as I'm doing that, also say the 7-segment display is has ground for the complete circuit is coming from the board, which is sending the voltage through the resistors that are right here, one for each digit pin for the 7-segment. That is then going to go to ground here, and then that ground is being supplied also from the board. So as you can see, the green light goes. I will also, give me 1 second to set up a timer here. So let me hit reset on the board itself, and then we'll hit go. And as this is going to also explain further, so the same thing as the 7-segment display is for the LEDs as well. The circuit goes power coming from the board, going into a resistor, and then they're all 100 ohm resistors for the LEDs from the board, because each resistor color requires different voltage input in order to output, emit light. And so it's going from the resistor to ground on the LED. So as you saw, we hit 30 seconds there. We're at yellow light now, and it's counting down from 10 or 9 to 0 in bit fashion. Now we go to red. And then as you can see here, we have the power going to the button here, that's pedestrian switch, and when pressed, it will then complete the circuit and send that signal into the board, and that will be picked up. So now we will show that. So now we're at a green light. Like any pedestrian light, when you click the pedestrian walk signal, it does not switch immediately. So I added a 5-second delay to account for this. I will show that in the code. So when I hit go, it'll 5 seconds go by. Now we're into yellow. It'll count down from 10 seconds again. 2, 1, 0. And then we go over to red. And then now we're back to green. Now let me stop this and I will show the code. Actually, sorry, let me go over to the code screen here. Okay, now we should be seeing the Kill UVision software. So I'm not going to show all the code for this. It will be attached in the report I am also writing for this project. Also further, because in case this project is redone in the future, so that people don't see all the code and they can kind of figure it out, because it was fun, as I'll explain here in a little bit. So as what you're seeing right here, we have this entire project consisted of 5 drivers, 2 of which were supplied in the and only one of them I took ideas from past code I wrote for past labs, or code that I was given but had manipulated to the lab requirements at the time. So as you can see here, we have I'm showing the interrupt from the main. The main holds the yellow light 7-segment display loop up above here. But right now we're focusing right here on line 78 to line 111. We have the GPIO port B handler. This will pass in the interrupt from that switch. And then this 5-sec global value right here is what's going to be counting down for the delay from green to yellow. So that is the delay you saw that I was previously talking about. Now we go on to the port E data. This is going to switch over to the yellow light. And then we count through port every time going through port B, the 7-segment values, 9 to 0 or 10 total. And then we end out the interrupt with BXLR. Port B, I'm just showing right here the particular interrupt values. So we're using a bit clear on 8 for all the edge to level, and then we set priority, and then the port B is at PRI 0, and then enable 0 for the NVICs there for port B. Next is port E, and this one, the main right here is the output coming from port E. So port E holds the green light, and then this will then pass back over to segment, which is a function or subroutine, and the main file back here. And then that will pass, the main file will go for yellow, that will go down here. That is if the interrupt is not going. And as seen, it does go without the interrupt needed, and it will go with the interrupt at any point in time as well. Besides, when it's a yellow light, you're not going to press it again. And when it's at a red light, you will not press it again. So at a green light, when you press pedestrian button, wait 5 seconds, and then it'll carry on to the yellow light. The other driver files here are just constant files. These are all the values for the board. And then same thing essentially here for the startup driver file. So I hope you learned something. Thank you for watching, and have a nice day. Bye.